Hello, this is the video project for Universal Physics 1 taught by Dr. Kevin Storr. We'll be going through a real-life example of a physics topic called the conservation of momentum in two dimensions. We'll be showing a real-life example by having a group of friends play pool and seeing how we can win the game by using physics. So please enjoy. Here we have Jamel, Joshua, and Carrie, three friends having a game of pool before their next class. Joshua is playing terribly, and even with Carrie's help, he can't seem to beat Jamel.
Man, we're losing right now. Wait a second. What did Dr. Storr teach us?
Alright, good afternoon, class. Thank you guys for coming to physics. You guys are clearly the only two people interested in your own education. So thank you so much. Let's just jump into a quick example of conservation of motion. Problem 9.12, it's a pool table scenario. We have two rotary balls, mass A and mass B. Their masses are going to be the same, and their mass is 0.16 kilograms. So mass A is 8. It's going to hit mass B. B is going to go off in this direction at an angle of 30 degrees. And this one is at an angle of -30. Okay, all right, and then so mass A is being in this direction at an angle of -30. The initial velocity of B is at rest, and the initial velocity of A is going to be 5 meters per second. And what this problem is simply asking is, what is the final velocity of both masses? Would anyone like to come up and start off to have something? Well, let's go. Here you go.
So, in the y direction, zero equals mass A times velocity prime of mass A sine theta prime A plus mass of B velocity prime B sine theta prime B.
Oh, and why is that 0?
Because there's no movement in the y direction. The signs, since they're the same, but they're equal but opposite, they'll cancel out. Leaving us with, the masses also cancel out because they're the same, leaving us with V of A prime plus, not plus,
Minus.
minus.
Yes, ma'am. Minus. It's minus.
It's minus.
B prime. My problem.
Then we will plug this into the x direction. Since Joshua knows this so well, he can come up here and solve the rest.
So, because this is equal to 0, we can set VA prime equal to VB prime. Right, class?
Yeah.
Absolutely.
And so, now we have, well, first of all, the reason why this sine angle, sine theta of 30, equals 1/2, the negative sine of theta equals -1/2. And so even though my counterpart did not explain this, That is why these two cancel out. So positive sine theta equal 1/2 and negative sine theta equal negative 1/2. So that's why the sine theta is canceled. So we have the equation of MA VA X equals MA VA prime cosine theta A prime plus mass B velocity A prime cosine B prime. Okay. And so the masses each cancel because as we discussed earlier, the masses of the balls are the same. So now we just have VAX equals VA prime, and we can combine like terms because VA prime and VA prime are both there, so we can combine like terms. So now we have cosine theta A prime plus cosine theta B prime. So to find VA prime by itself, what do we do, class?
Come on, you should know this.
I'm glad you asked. We're gonna divide this over VAX to get B prime by itself. So we have VAX over cosine theta A prime plus cosine theta B prime equals VA prime. Once again, we have to divide to get VA prime by itself. So now we just plug in our variables. So the original velocity of A was 5 meters per second, so we plug that in to VAX, 5 meters per second, over, and cosine of 30 degrees is what, class? Square root of 3 over 2, right? Square root of 3 over 2, yes. And so, because the cosine thetas are the same, we have cosine 2 cosine 30 degrees, which equals 5 meters per second, over 2 times square root of 3 over 2. Since as we discussed, 30 degrees is square root of 3 over 2. Do the math here. Compute this.
5 over 3.
Somebody gonna compute this? I'll compute this, class. So whenever we compute this variable, VA prime equals 2.887 meters per second. And that is your answer for VA prime and VB prime. They're both the same. So your final answers are VA prime equals 2.887 meters per second, and VB prime also equals 2.887 meters per second. Thank you very much, Dr. Stewart. We are thankful for your class.
All right, thank you. Great work. Dude. Okay.
Joshua and Gary used Dr. Store's lesson to help them win the game. Using a protractor, they began to measure the force needed to make their next shot.
Yeah, right. Okay, that goes right.
After one final check with the protractor, Joshua shoots and scores.